Chapter 8. Change. Change is the only constant. Heraclitus. Imagine a world where everything remains static, devoid of blooming flowers, singing birds, and new adventures. Like a magical spell, change infuses our world with excitement and beauty, transforming caterpillars into butterflies and tiny seeds into towering trees. This chapter explores the incredible ways in which change shapes our universe, from the twinkling stars in the sky to the rhythmic beating of our hearts. Change is the fundamental essence of the universe, permeating every aspect of existence, from the microscopic to the cosmic scales. It is not just a constant, but an inexorable force driving the evolution of stars, galaxies, and the very structure of space and time. From the intricate interplay of particles governed by quantum fluctuations to the majestic orchestration of galaxies colliding and merging, the universe is a dynamic canvas where transformations unfold ceaselessly. This chapter delves into the nature of change and the causes and consequences of change in terms of philosophy and biology. Philosophical approach to change. In philosophical terms, changes in an entity can be broadly categorized into qualitative and quantitative changes. Additionally, Aristotle's framework introduces further distinctions, such as substantial and accidental changes, providing a more nuanced understanding. Qualitative changes involve alterations in the qualities or properties of an entity. For example, consider a leaf that changes color from green to yellow during autumn. The leaf remains the same entity, but its color, a property of the leaf, changes. Similarly, when iron rusts, it undergoes a qualitative change as its surface transforms from smooth and metallic to rough and reddish due to oxidation. These changes affect the attributes of the entity without altering its fundamental nature. Quantitative changes refer to modifications in the quantity or amount of an entity. An example is a plant growing taller over time. Another instance of quantitative change is the addition of water to a glass. The water's volume increases, but the water itself remains fundamentally unchanged. These changes involve alterations in the entity's characteristics, size, number, or extent. Aristotle's classification provides a more detailed understanding of changes by introducing the concepts of substantial and accidental changes. Substantial change involves the coming into existence or passing away of a substance. For example, when a seed germinates and grows into a tree, the seed undergoes a substantial change as it transforms into a new substance, the tree. Conversely, when a tree is cut down and processed into lumber, the tree ceases to exist as a substance and a new substance, lumber, is created. Accidental changes do not affect the substance itself, but alter its properties. These are further divided into qualitative, quantitative, locomotion, and relational change. As mentioned earlier, qualitative changes involve alterations in properties such as color or texture. Quantitative changes include growth and diminution, like a child's increasing height or a candle burning down. Locomotion involves changes in the place or position of an entity, such as a car moving from one location to another. Relational change occurs when the relationships between entities are altered. For example, when a student graduates and becomes a teacher, the individual's relational status changes within the educational context. An appreciation of change and the types of changes helps in analyzing the nature of transformation within entities and the principles governing such transformations. Different philosophical traditions may emphasize different aspects or propose additional nuances, but these categories form a foundational basis for exploring how entities change in the physical world. Change is everywhere, and everything changes. Therefore, change is an important philosophical dimension of existence. Change is the variation or perturbation in an entity's matter, composition, energy, shape, structure, morphology, organization, position, and emergent properties. All emergent properties are dependent on the material and energy components. We should agree that all change has a physical basis, matter, energy, or position. Even aspects like magnetism, emotion, or thought still have a physical basis at the micro level: quarks, atoms, molecules, cells, tissues, and connections. Therefore, we shall consider change as a physical property. Change in space, such as in outer space, is a change in the physical universe. Every change in the universe must be attributed to the physical universe at the macro or micro level. Change in an entity is the difference between the entity's state, physical, chemical, and positional, at two different time points. Suppose an entity has remained the same between the time points of observation. In that case, one can say that there is no change in the entity, or that the entity is unchanged during that period. Change is the spatial and organizational difference on a temporal scale. The universe is constantly changing. Some humongous changes, such as the collision of galaxies, and minuscule changes, such as the revolution of the electron or a river flowing. Change is imminent and constant. From the time when there was just space to the end when the universe dies, change rules. Every entity's existence, extinction, and evolution is a tiny wave in the landscape of change. Change is proportional to the difference between the time points, as long as all the minutest details of the whole universe are accounted for. The concept of change in observation is not just about the transformation of an object from one state to another, but also about the timing and frequency of observation. Consider an object that changes shape from a cube to a sphere and then back to a cube precisely as before. If we observe this object at two different time points, say time point 1 and time point 2, where it appears as a cube both times, one might question whether there was any change. This scenario highlights the importance of accounting for the time points of observation. Why is there a change? The universe is in a constant state of change due to several fundamental processes and principles that govern its behavior. Most of the reasons are grounded in physics, nuclear physics, and astronomy. So we shall only touch on these topics briefly. One perception is invaluable. Change is brought about by energy and forces, manifesting in both physical entities and the energy itself. In the physical realm, changes occur when energy is applied to objects, altering their state, position, or structure. For instance, the application of thermal energy can change the state of water from solid to liquid, while gravitational forces can alter the trajectory of a celestial body. Several factors are directly involved in the operator called change. Change happens to an entity, which could affect the system in which the entity is present. Below are some of the important factors. 1. Interconnected components. The universe is a continuum of many components that interact or influence each other. This interconnectedness means that a change in one entity often triggers changes in others, creating a chain of continuous transformations, a contagium and continuum of change. For example, the formation of a new star can influence the surrounding interstellar medium, leading to the creation of new planetary systems. These interactions ensure that the chain of changes will continue, a continuum of change. 2. Cosmic expansion. According to the Big Bang Theory, the universe has been expanding since its inception. This expansion causes galaxies to move away from each other over time. The rate of this expansion is described by Hubble's law, which relates the velocity at which a galaxy is moving away from us to its distance. This expansion itself is a fundamental change, and all of existence is grounded in inherent change. 3. Thermodynamics. The second law of thermodynamics states that the entropy of an isolated system always increases over time. Entropy is a measure of disorder or randomness. As entropy increases, the universe evolves from a state of lower disorder to higher disorder. This principle drives many changes in the universe, including the evolution of stars, the formation of galaxies, and the eventual heat death of the universe. 4. Energy and mass distribution. The energy content of the universe is disproportionate to the mass and unevenly distributed among various entities. This imbalance fuels interactions and influences between different components, driving change. The entities have differences in mass, so there is a difference in the gravitational force they exert. Similarly, the energy is disproportionate among the entities. The stars have enormous energy, which is radiated out onto the surrounding entities. The type of energy the entities possess can also exert attraction or repulsion among entities. These factors could trigger a cascade of changes. The movement of energy and matter drives interactions between components, and interactions cause change until absolute universal equilibrium is attained. Movement from regions of high to low concentration occurs due to diffusion, driven by molecular kinetic energy and, in some cases, electrostatic interactions involving attraction and repulsion. Similarly, movement from high to low altitude is primarily influenced by gravitational forces and pressure differentials rather than direct molecular interactions. 5. The four fundamental forces. The universe is governed by four fundamental forces: gravity, electromagnetism, the strong nuclear force, and the weak nuclear force. These forces impart attraction or repulsion, which means that these forces are likely to interact with and influence the behavior of adjacent objects. My favorites are gravity and magnetism because they can influence other objects without making physical contact or energy transfer. 6. Quantum fluctuations. Quantum mechanics dictates that particles and fields fluctuate on the smallest scales. Quantum fluctuations in the early universe are also thought to have given rise to the large-scale structures we observe today. Change is inherent to energy and in all the matter. Until the heat death, change reigns. Here's a little truism for you. Unchanging things do not change, and changing things do change until they change into things that do not. This statement is logically true, similar to the equation 1 + 1 = 2, and it surprisingly offers strong predictions about how the world operates. If every changing thing can indeed transform into an unchanging thing, then it follows that we should anticipate all changing things eventually transitioning into unchanging ones. It is like saying, it is a dog because it is a dog. Prof. Adi Pras of Ben Gurion University.